This is unit number 2. It's on systems of linear equations. And I think to start, we'll do some definitions. You see here mentioned the first part of the unit, systems of linear equations in two variables. Okay, so think about if you had 3x minus 2. If you see something like this, it's called an algebraic expression. It's not an equation because we have no equal sign. If we add a number on the back, 3x minus 2 equals 0, we have an equation, a linear equation in one variable. The variable is x. So linear equation in one variable. So the variable here is x. Okay, but the topic today, simple linear equations in two variables. So as an example, x plus y is 5. If you go back to this example here, we can find x, can't we? We'd have 3x equals 2. We bring the minus 2 over, and x would be 2/3. So we can solve it. But in this question, you can see there's more than one answer. So what two numbers add to be 5? You could have 1 plus 4. So in this case, x equals 1, y equals 4. You could have 2 plus 3, which is also equal to 5. So then x is 2, y is 3, etc. So when you have two variables, but one equation, we have multiple answers, so more than one answer. In this example, we only had one answer. We had one variable, one equation. But in this case, we have two variables, but still only one equation. So we have multiple answers for the question. And we'll look at that next. So in part 1, let's look at this example. We have a plate with 10 oranges and rose apples on it. 10 fruit in total. If the number of oranges on this plate is x and the number of rose apples is y, then we can write the equation x plus y equals 10. And as I just said, this has multiple answers. So, and they're made into a table here. So for example, if x is 1, y must be 9, isn't it? So we'll get 10. If x is 2, y must be 8. So 8 plus 2 is 10, etc. So we get a whole series of answers to the question. So what we do, we write them down as coordinates or ordered pairs. These are called ordered pairs. So the first pair is 1, 9, and then we mark it in our graph here where x is the x-axis and y is on this axis, that's the y-axis. So our first point is 1, 9, which is here. Okay, and then the next ordered pair is 2, 8, and we mark them here. X is 2, y is 8. So 2, 8, and so on. And you can see here, we're going to get a straight line because it's a linear equation. Okay, so that equation there is x plus y equals 10. It could be written as y equals minus x plus 10, which you will do more on later. So that is your equation of this line here. So just to reiterate, the equation x plus y equals 10 is a linear equation in two variables, and the variables are x and y. And the solutions of the equation are the ordered pairs of positive integers only, because we can't have negative fruit, can we? So we have only positive numbers of fruit. Therefore, the graph is a set of points along a line segment. In exercise 1, let's think a bit about this. It's a statement. Dillard has 5 pens more than Chinon. Okay, so can we say how many pens Dillard and Chinon have each? So in this case, you have to answer yes or no. Just from that statement, can we tell how many they have each? Now, if Dillard has 7 pens, how many pens does Chinon have? I think you can answer that. If Chinon has 4 pens, how many pens does Dillard have? We can answer that as well. If the number of pens of either Dillard or Chinon is given, can the rest of Chinon's or Dillard's pens be found? So you answer that as yes or no. That's all. And I want the answer to that one. So now this is solving the graph. So given that the number of Dillard's pens is x and the number of Chinon's pens is y, so we write down the equation x minus y equals 5. And that equation comes from the original statement. So as before, we write down the set of ordered pairs. And in this question, it's had 2 done already, these 2 here. So it looks like the line will go up in this direction here. So you need to add some more points here, okay, and draw your line. You actually don't need to draw the line. I just mark the actual point because there is actually no number between these. These are discrete values because we can't have fractions of fruit. So we can't have 8.5 apples or 6 1/4 pears or something like that. So these actually don't actually draw the line, just draw the actual points. Okay, so don't join them with a line. And you can answer that. You just write down what you think should be written there, and I'll give you some ideas later on. I'm guessing you're probably not going to know the answer that's in my answer key, but we'll see. So here's example 1. The difference between 2 integers is 2. Okay, difference means when you subtract them, you get 2. Difference is subtraction. So if you've got 2 integers, x minus y, the difference between the 2 integers is 2. And then as before, we make up a set of ordered pairs where x minus y is 2. For example, 2 minus 0 is 2, 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2. And then we make our set of ordered pairs, and then we put the points into the graph along that. Okay. Now, in example 2, we have 2 sets of graphs. Okay, so the first part says the sum of 2 numbers is 3 and their difference is 1. So that means that the sum of 2 numbers, x and y, is 3. Let's call that equation 1. And their difference is 1. So when you subtract them, you'll get 1. That's equation 2. Okay, and then we do 2 sets of graphs. Okay. Thus, the system of linear equations consists of 2 equations, x plus y equals 3, that's this one, and x minus y equals 1, this one here. And then we are going to put them both into the same set of axes. So we draw the two lines and notice we have an intersection point here. This is your solution to the problem. These are the only two sets of numbers that satisfy both equations. So if we look at our original equations, x plus y equals 3, and the other one is x minus y equals 1. These two numbers are the only two numbers that work in both equations. So for example, if we put 2 in for x, 2 plus y is 1, we get 3, correct. Then in this one, we put 2 minus the y value, which is 1, and we get 1, which is correct. So this is the solution to both equations. If you pick another point, for example here, 5 and 4, 5 and 4 will work in this equation, but it will not work in this equation. Okay, these are the only two numbers that satisfy both equations. And that's your solution to the system, 2, 1. Okay. Example 3 is done exactly the same way. The sum of two numbers is 4. X plus y equals 4. And their difference is 1. So when you subtract the two numbers, you'll get 1. So we get two sets of graphs as before, and we draw the two lines. So be careful here, especially if you're drawing your own graphs. If you're not using a tablet, you need to be careful with these because you may end up with fraction answers. So take care with that when you're drawing graphs. Okay, I recommend you print this document to do these. If you draw them by hand, you may make errors with your axes and finding these points. Okay, so that one ended up as having decimal answers. So in this case, your solution is 2.5, 1.5, which you may not get accurately if you're drawing by hand. Okay, so in exercise 2, this is what you need to do. I'll start you off. The sum of two numbers, so let your two numbers be x and y. That's what we normally do, x and y. And it says the sum is 6, so that means you're going to have x plus y equals 6 as your first equation. And one number is twice another number. So that could be 2x equals y. So double the x number will give you the y number. You could also have x equals 2y, and you should end up with the same answer at the end. So you choose which one. I recommend use this one, but see what happens. So then draw your two graphs. So x plus y equals 6 and y equals 2x. And then draw your two graphs. And then look at where you find your intersection point, and that will be your solution to the question. And then you can write that solution down here. Okay. So again, here's another question, question 2. And I want you to start reviewing all of the previous work. So we've got a few questions here on cone. This is on a pyramid. So this is a cone and a hemisphere. And also spheres here. So each section of work you get now will have review of old work. That will help you remember the material. Okay, I'll talk to you in the next lesson.